Hello and welcome to 3.2 two-step equation solving. This is unit 3 in equation solving, and we're going to be working on extra pizzazz pages in class to help solidify this concept. The pizzazz pages would be 34 through 39. Please make sure that you add in your name and date along with making sure that we have a very clear handwriting when we're taking these notes. So now that we've taken care with the header, we're going to go ahead and start with some vocabulary words. The first vocabulary word we're going to start with is isolate a variable. So the idea here is isolate is the vocabulary word we're working with, and we're isolating in terms of working to isolate a specific variable. And reminder, variables are letters. So, when we take a look at this, we want to undo operations that cause a variable to be alone. So, we're going to undo the operations until the variable is completely by itself. You can kind of think about isolate as though it would be on an isolated desert island. We often talk about that. So, we're trying to get it all by itself. The next vocabulary we're going to review is a balanced equation. So when we talk about a balanced equation, we're working on really manipulating the equation so that what you do to one side of the equation, or the equal sign, you do to the other side of the equal sign. So again, any type of manipulation to make it balanced, you're going to want, if you are adding 13 to one side, you need to add 13 to the other side. And we'll continue to work on a balanced equation all the way throughout equation solving. It's something that comes up in each and every single situation that we talk about with equation solving. So now we're going to head to our key concepts, where we're going to take a look at the method for solving two-step equations. So two-step equations is actually a great name for this because there are, in fact, two general steps that happen. I'm going to break up this process into 6 different steps and identify a lot of the nuances and details that we really want you to know about. So when we take a look, the first thing we want to take a look at is, if possible, we want to simplify each side of the equation. So if we have any like terms that we want to combine, we want to go ahead and do that. If we have any subtraction, we want to change it to adding the opposite. I promise that will really help us out. The one type where I would suggest maybe waiting to simplify is if you look at an equation and it says distributive property. And that'll happen in our next video or two, that we'll discuss what we would do when we have distributive property in an equation situation. Since that's not what we're talking about now, the first step we really just want to pick out is we're going to simplify. So, if possible, sometimes it's already as simplified as it can be. Step 2 is asking us to identify the types of operations. And when we look at this, types is plural because there should be 2 operations if this is a two-step equation. So the question we really want to ask ourselves is, what's happening to the variable? And in specifics, we're going to have 2 types of operations. So something that's happening to a variable in a two-step equation could be multiplication and addition. It could be multiplication and subtraction. It also could be division and addition, or division and subtraction. So we'll go through a couple of those pieces and give you a few examples of what those mixtures could look like. Let's go ahead to step 3. And step 3 is asking us to undo the term that is being added or subtracted. So there's a term on the side of the variable that's being added or subtracted. We're going to undo that first. And then we're going to go ahead with step 4 and undo the number that is either being that is either being multiplied or divided. So to start with, we want to get rid of the terms that are away from the x, and then we also want to get rid of the term that's being multiplied or divided by the x. The fifth step is to check. So when we check our answer, this looks like rewriting the original equation, substituting our solution that we're pretty sure is our solution, and simplifying by using order of operations. The last thing we do once we have our check and find that our solution works in fact, we're going to box in our answer. Now that we've taken care of the key method, let's go ahead and take a look at an example right off the bat. Now our first example we're going to work with is going to say 3x plus 2 is in fact equal to 10. And what we're going to do is first simplify if possible. So I'm going to take a look over at this side here, and I'm going to say, hey, can I simplify, not all the way over there, simplify 3x plus 2? And I can't, and I don't have any subtraction, so I don't need to add the opposite yet, and 3x and 2 can't be combined. So I leave that alone. And 10 on this side over here is all by itself, so I can't simplify that either. So then that leaves me with starting along the process and identifying the types of operations. So when I take a look here, 3x, that's multiplication, and this plus sign here is addition. So the two types of operations I have are multiplication and addition. With that being said, let's go ahead and step 3 asks me to undo the term being added or subtracted. Now I have this plus 2, so I'm going to take the inverse and subtract 2. That's going to leave me with 3x is equal to 8. In solving, my next step to go ahead is going to be to undo the term being multiplied or divided. So I'm going to go ahead and say this 3x is multiplied, so I'm going to divide both sides by 3. And I believe then my answer is going to give me x is equal to, let's make that look like an x, is equal to 8 divided by 3, which also is the same thing as 6 2/3. When I do my check, I'm going to want to use the improper fraction here, as opposed to the mixed number. The improper fraction allows me to go ahead and cancel if it's possible. And rather, I didn't use that very well. So there are in fact 2 3's that go into 8. So let me go back a step and fix that. So 8 divided by 3, there are 2 3's that can go in evenly, with 2 left over and 3, in fact, in my denominator. So let's go ahead and check that again. I still do want to use this 8/3 as my improper fraction when I check. So I'm going to go ahead and check right now. I label the check and I go ahead and rewrite the original equation. So that original equation was 3x plus 2 equals 10. And now I'm going to substitute, once I've rewritten my equation, that 3 is going to be multiplied by 8 over 3. So I'm going to leave a space there and I'm going to plug in, I believe my answer to be 8 over 3. And by doing that, I can recognize and remember that I can have that 3 be divided by 1. I can look to cross cancel because now I'm at the point where I'm solving. There's 1 3 there and there. And that gives me a simplified version of 8 plus 2 equal to 10, or 10 equal to 10. I did check, that does work, so I can go ahead and box in my answer. Excellent. So either idea of x equals to 8 over 3 or x equals to 2 and 2/3, either one will work. Let's go ahead and take a look at a couple more examples where we have two-step equations. Now we're on the back side of the sheet and we're going to add in our section title here to as a continuation. So we're going to write 3.2 two-step. Since we've added our section title to the back, we're now going to do a few more examples. We don't have any vocabulary or key concepts to add on this time. So our next example we're going to work with is going to be when we have an x term that might be a little confusing to recognize that it's a two-step equation as opposed to a one-step equation. So let's take a look at this and be really conscious of why we could identify this as a two-step equation. So the first, we're going to write, this is example number 2, and we're going to write 11 minus x is equal to 37. Now you might say, hey, there's only one thing that's happening to x here. But when we start off with that first step and it asks us, if possible, to simplify each side, I'm going to be able to simplify this by adding the opposite. The type of operation that's happening currently is that x is being added by 11 and being multiplied by an invisible -1. So be very careful with a problem where you have a number being subtracted by x. So now I've identified I have adding by 11 and multiplying by -1. We're going to go ahead and solve these. So I'm taking care of step 1 and 2. Step 3 says to undo the term being added or subtracted. The 11 is being added, so I'm going to undo it by subtracting 11 on both sides. I get -1x, or negative x, your choice, is equal to 26. When I take a look at this, I now have a -1 being multiplied by x, so I want to go ahead and undo that. I can divide by -1 on both sides. Again, that's the balancing if I do it on both sides of the equal sign. And I'm going to end up with x is equal to a -26. Now let's go ahead and check that equation to see how we did. And I'm going to label the check and rewrite my original. And my original is 11 minus x is equal to 37. The next step in the check is to substitute, so I'm going to have 11, and where I see x, we're going to minus the number I believe to be true. And here the number is -26. When I see subtracting a minus sign, I'm going to go ahead and make it a plus plus. Let's change that into a different color that you can see the plus plus. So this gives me then 11 plus 26 is equal to 37. If I add 11 and 26 together, in fact, I do get 37. My solution checks out, and I can box in my answer of x equal to negative 26. The next problem we're going to try out, let's go ahead and grab that. The third example we're going to work with is going to have a fraction, and we will have a fractional answer, and it will check out to be splendid because fractions are our friends. So here we go. We're going to take a 2/3 x and add 12 and equal 9. So 2/3 x plus 12 equals 9. Here I cannot simplify on the left side or the right side of the equal sign, so I get to go ahead and just identify the two things that are happening. I am noticing that right here I have multiplied 2/3 by x, and here I'm adding 12. So I need to do the inverse. So first of all, we take care of what's being added or subtracted to x, or the x term rather. And so we're going to subtract 12 from both sides. That's going to leave me with 2/3 x is equal to negative 3. 2/3 x equals negative 3. In order to divide by a fraction, it's the same thing as multiplying by its reciprocal. So I can do that and multiply by 3/2 on both sides of this equal sign. Recognizing that I can make a negative 3 into a fraction as well if I divide that by 1. Lucky for us, we get a few things that cancel. So we'll end up that this simply becomes x on that side. And over here we get negative 9 divided by 2. Let's go ahead and check that answer. We're going to work with the original equation of 2/3 x is 2/3 x plus 12 is equal to 9. I'm going to substitute negative 9/2 in for the x, so we're going to still rewrite 2/3 times negative 9/2 plus 12 is equal to 9. I do have a few things that can be cross-canceled here, so there is a 1, 2 in each of those 2's. And there is 1, 3 here and a negative 3 here. That would give me a negative 3 plus 12 should equal 9. And in fact, negative 3 plus 12 does equal 9. Because that checks out, I can go ahead and box in my answer. Let's do a try on your own now. So the fourth problem you're seeing should be a try on your own. Let's add that in here. And here we're having you try on your own negative 16 is equal to 2x plus 4. And if you don't like having the x on the right-hand side of the equal sign, this is the same thing as saying 2x plus 4 is equal to negative 16. You can rewrite them as long as they are the exact same pieces flip-flopped around. All right, we'll go ahead and check this in class, and thank you for your time.